Peace be upon you and God's mercy and blessings. God willing, in this lecture, we will talk about CT polarity and CT star point concerning the current transformer polarity. There are two types, subtractive polarity and additive polarity. For subtractive polarity, the CT is drawn in this way, and in this case, the directions of the currents are such that if the primary current passes in this direction, the secondary current will pass in this direction, which we can say is opposite to the direction of the primary current. This means that in the case of subtractive polarity, the CT dot points are drawn next to each other in the primary and secondary, and if the primary current is moving towards or entering the dot points, the secondary current will be exiting the dot points. As for additive polarity, the CT is drawn in this way, and in this case, the directions of the currents are such that if the primary current passes in this direction, the secondary current will pass in the direction which is, we can say, the same direction as the primary current. This means that in the case of additive polarity, the CT dot points are drawn apart from each other in the primary and secondary. And if the primary current is moving towards or entering the dot points, the secondary current will also be exiting the dot points. However, this time the dot points will be at the opposite end of the CT compared to the subtractive polarity case. So where do these terms subtractive and additive come from? If we take a small transformer with a turns ratio of 1:1 and we applied a voltage, let's say with a value V. On the primary side, this voltage will definitely transfer to the secondary side with the same value. However, it will be either in this direction or that direction depending on the winding direction of the coils. If we connect one terminal from the primary with one terminal from the secondary in this manner, and connect a voltmeter between the other two terminals in this way, then based on the winding direction of the coils, the voltmeter reading will be the difference between the two voltages, meaning 0. And in this case, we say the polarity is subtracted. Or the voltmeter reading could be the sum of the two voltages, meaning 2V. And in this case, we say the polarity is additive. Instead of changing the winding direction of the coils, we can reverse the terminals of the secondary side so that if the current enters at P1, it exits at S1. However, sometimes we will notice that S1 is next to P1, which is in the case of subtractive polarity, and other times we will find it on the other side, which is in the case of additive polarity. This is exactly what we explained earlier with the dot points drawing method. Very good. Now let's take a look together at the topic of the city star point. We will take an example of a single bus single breaker scheme and use a city with subtractive polarity. We assume that the primary current is exiting the bus bar towards the feeder, whether this feeder is incoming or outgoing, and thus the secondary current will be in this direction. We will start connecting the three in the city so that the star point, which is the neutral point, is towards the feeder that E will be connected to the protected object. The other terminals of the city will be connected to the relay city input dot point. In this case, the setting of the city polarity inside the relay will be towards the line or standard, depending on the naming in each relay. Consequently, the relay will see the current with its angle and add a 0 angle to it, so the power reading will be correct whether it is exported or imported. Also, if I have any protection that depends on directions, meaning the direction of the current, it will also work correctly. Now, if we connect the city terminal to the relay city input, but not to the relay dot point, and the city was the relay will see the current with its angle added to 180 degrees because it will see the current coming out from the relay's dot point, not entering it as in the previous case. Consequently, the power reading will be incorrect, meaning it will be reversed, the exported will become imported, and the imported will become exported. Also, if I have any protection that relies on directionality, the forward will become reverse, and the reverse will become forward. So, what is the solution? The solution is to change it so that in this case, the relay adds 180 degrees to the current's angle in addition to the 180 degrees caused by the incorrect connection on the relay. Thus, it's as if I cancelled out these 180 degrees, and the final angle will be the actual angle of the current, making it correct and function properly. All right, let's see together. If the city star point is in the direction of the passport and the other terminal of the city is connected to the relay city input dot point. If we set the city polarity inside the relay towards line, in this case, the relay will read the current with its angle plus 180 degrees because it sees the current coming out from the dot point of the relay. Therefore, the power reading will be incorrect and the direction protection will operate incorrectly. So, what would the solution be? The solution is to change the polarity setting in the relay and set it towards space. In this case, the relay will add 180 degrees to the current angle in addition to the 180 degrees caused by the incorrect connection on the relay. Thus, it's as if I cancelled out these 180 degrees, and the resulting angle will be the actual current angle. Consequently, the power measurements will be correct and the directional protection will operate properly. This way, we have understood the topic of city polarity and city star point.